so now let's look at problem 2.2. For an electron in a 15 electron volt deep one-dimensional rectangular well of width 2 angstrom, we need to find the number of bound states. So if you look at the equation for number of bound states, this is equation 2.36 that tells you the number of bound states. N is greater than or equal to B over pi, where the constant B is given by 2mv0, square root of that, times L over h bar. So some of the things we need would be the mass, in which case we're looking at the mass of an electron. So that is this. And we have the potential given in EV. So just to convert electron volt to joule, I just have the conversion factor listed here. So we need to compute B over pi to figure out the value of N. So B over pi would be root 2mv0 times L over h bar is nothing but h over 2 pi, right? Now this is B divided by pi. So let's just cancel this out. And now let's plug in the values, right? So the values would be 2 times 9.1 into 10 to the power minus 31 kilograms times 15. Instead of electron volt, we're going to convert that to joule. So 15 times 1.6 into 10 to the power minus 19 joules to the power half, times the length is 2 angstrom, so that is 10 to the power minus 10 meters, times 2 divided by the Planck's constant, which is 6.626 into 10 to the power minus 34 joules second. And once we have this, we can plug in the values. And let me actually do that. Let me also show you how the units make sense. Sorry, my bad. Yeah. Okay, so now if you're looking, okay, once we have this, let me actually show you how the units work out. So kilograms times joules. A joule is nothing but 1 Newton meter, and we can write that as a Newton, we can write it as 1 kg meter per second squared times, we have the meter there. So if we look at it, we have kilogram squared, meter squared per second squared. Now, the unit kilogram and joule, they're under the square root. So when you take the square root of that, you actually get this. Okay, so now let's plug in the values for this and see what happens. Okay, I just realized that I did not explain what happens with um, meter per joule second. So let's just do the same thing we did. Joule is essentially kg meter per second squared. Uh, Meter, yes. From here, I'm just taking this value for joule and plugging it in. Sorry about that. That will be uh, kg inverse, meter inverse, and we have second. Yeah, so that's how I got the unit there. And this clearly gets canceled. The units gets canceled out, which makes sense because we're looking at the number of pound seeds, which is a number, it's a unitless quantity. And I did this just to show that the units beautifully get canceled during this process, and it's important to actually write the units and see what's going on with them. Things would make sense. And if you do this, the value would be 1.26. So we know that the number of bound states is greater than or equal to b over pi, which is 1.26. So your n is greater than or equal to 1.26, which means your n is going to